Hi guys, and welcome to Journey Through to the Centre of the Earth. This is Activity 6 for Year 9, where we're going to look at what happens when a continental plate meets an oceanic plate. Okay, so here we've got a diagram of the two plates meeting together. We've got the oceanic plate on the left-hand side and the continental plate on the right-hand side. Now the first thing that we need to notice is the thickness of the two plates. We notice that the oceanic plate from the oceanic crust down to the bottom of the lithosphere is a lot thinner than the continental plate from the continental crust down to the bottom of the lithosphere. The result is the continental plate is a lot heavier and it's going to be carrying a huge amount of mass, whereas the oceanic plate will be quite small in comparison. As a result, there is no way the oceanic crust, the oceanic plate, is going to force this continental plate downwards. The only thing that's going to happen is the continental plate is going to push the oceanic plate underneath and form what we call a subduction zone. So that's the first thing that we need to notice, is that the oceanic plate, when it meets a continental plate, will always undergo subduction and be pushed downwards. At the interface between the two plates, we're going to get an incredibly deep trench. Now around the world we will see lots of these trenches, for example the Marianas Trench. And this is just at the point where the oceanic plate slips away from the continental plate. As the continental plate is pushing from right to left, we're going to get friction, and that friction is going to generate folding. Now the folding is going to cause this part of the continental crust to rise upwards. So as a result, what we get is quite mountainous ranges which are formed along all these areas. Now these mountain ranges will have cracks in them, and as a result, what will happen is any of the melted lava which is generated from the subduction zone will filter upwards because it becomes less dense, will filter upwards and go through the cracks. Plugs are formed in craters of these volcanoes, and the result is that these plugs will hold that lava in. But eventually the pressure gets so great that the plug can't hold it any further, and as a result the volcano erupts. So there are four main areas or things that we need to consider when we're looking at an ocean plate meeting a continental plate. We get subduction of the ocean plate, we get a deep trench at their interface, we get folding causing mountains, which can then lead to volcanoes, and we get melting of the subduction zone, which causes huge pressure due to lava buildup, and we get the generation of a volcano. So where around the world does this occur? If we look at the two maps that we've got on this slide, we can see the left-hand map, one we've seen earlier, shows the movement of the plates. Now the plates, basically, you can see down the mid-Atlantic ridge, where we've got straight red lines, just means that they're pulling apart. But where we've got red triangles means that the plate is actually slipping underneath the other plate, and as a result we've got a subduction zone. For example, here is India, which is slipping underneath the Asian plate, which is what was the generation of the Himalayan mountains, which we discussed earlier. Now, what I'd like you to identify is on the right-hand map, all the red dots are going to identify volcanic action. Now, if we look down the western seaboard of North America and South America, we can see we've got huge numbers of red dots. This shows us a lot of volcanic action. Now, volcanoes, as we were aware, is caused where an oceanic plate drives into a continental plate. Well, let's just find them on the previous map. Look where the cursor is. We can see on the west of South America and the west of North America, there are our subduction zones. Our subduction zones, as a result, basically are the generation of these volcanic areas. We'll also get the same if we look on the east coast of Asia and around through New Zealand. And if we follow those plates on the previous map, you can see there's the top bit, there's the subduction here, and look, there's the subduction where the volcanoes are formed. Look down the east coast and through Japan and all those areas, we can see there are all our volcanic areas. Same going through this area here, we can see just off Australia, we've got the volcanic areas here, and then here is New Zealand, and then we've got volcanic action acting down here as well. We've got subduction. So you can see throughout the ring of fire, it's all generated due to the production of these subduction zones. Okay, so as a result, we'll know that because these are slipping underneath all the time, these continents are moving in this direction, in this direction, which means the Pacific Ocean is actually getting smaller. And if you remember a couple of activities before, the Atlantic Ocean is getting bigger due to the plates moving outwards. This is compensated by the Pacific plates basically slipping underneath. Okay, so I hope that makes sense as to what happens when we get an oceanic plate colliding with a continental plate. Join me again and for the last activity where we're going to look at plate movement. Thank you for watching.